Nikica will be talking to you about how to treat your data right. So please give him a warm up.
Hi everyone. My name is Nikica Jokić, and I'll be talking about aggregating data consistently and accountably. So just a few bits of information about myself. I work in Aggregating. We do JavaScript and design consulting, so if you're looking for high-end JavaScript work, you should check us out. Consistently and accountably, what does that even mean? So accountably means that all the mutations in your system, all the data mutations should be tracked and accounted for, meaning you should know what's happening with your data. And consistently means that all the inconsistent states that data can have are prevented or are solvable at least. So we'll see exactly how to do these things a bit later, but now we'll first start with our code. It says that every large enough software system, once it grows to a certain size, starts exhibiting, every large enough software system has a badly implemented subset of gifts contained within itself. I found this quote on Hacker News a while ago, and I really like it because I think it describes the problem we are talking about today quite nicely. And I think it's saying that large systems start exhibiting these features once they grow to a certain size, where data inexplicably gets chained, and you have transient bugs that you don't know how to track, and then you start exhibiting certain behaviors where you're freaking out because you don't have any clue about what's happening in your system. And we had a similar situation to that. So whenever things start getting complex like that, people usually respond by wanting to write things down because that's easier. It's easier to break things apart when you write them down. And I think that is exactly what Git does for your code base. It writes things down and makes the changes of the code manageable. So we had a similar technique to solve our data inconsistencies. So, but first let's define a problem a bit more precisely. So in Mitomi we have an internal project that was supposed to fetch data from RSS feeds and analyze the data and do something with it for a while. And after a while, as things tend to go in software projects, there was another requirement that said we should also fetch data from GitHub, and then of course came Twitter, and then Facebook and Reddit, and you can guess where this is going. So then Tumblr, Meetup, and there are some other feeds we track. So after a while, we created basically a monster that we didn't know how to contain all the data coming in. And so let me show you a couple of bugs that caused us to freak out and look for other solutions. So let's see let's explain the problem based on the example from Reddit. So we have this crawler thing in our system that fetches submissions and replies from Reddit. So if you don't know what Reddit is, it's an internet forum of sorts where people basically post pictures of cats and other people reply to that. And we're fetching submissions and replies from Reddit and storing them to our system. So let's see what's happening. We have the source, that is Reddit, and we have our system, and these are going to be the states as they are Reddit in our system. So we figured that system state can change seemingly at random at certain times. So what was happening? Somebody submits something on Reddit. Our crawler sees that submission and fetches it, stores it in our system. After a while, two things happen. You can see that there was a typo in the previous submission. The original author figured out that there was a typo and added, corrected. And there was a reply by somebody else. Well, in this example, I did both the submission and the reply. And our crawler sees something that's happened, gets the reply, but because of a code in the system, forgets to update the original submission. So our submission is stale, and submission in source on Reddit has the correct state. And then a while later, our crawler figures out that there was a change in the original submission and corrects that. So for a while there, we had a transient bug. We had a state that not immediately, but after a few seconds disappeared. So if you have a bug in your code and something like this is happening in your system, it's very hard to track exactly what is happening. So let me first show another problem, and then we'll move on to the solution. we had a problem where it's really hard to filter out noisy data. So again, we are fetching things from Reddit, and we first there's the same submission, and there's a reply, there's another reply, and our crawler sees all those, fetches them, and in turn sends them to our backend system. And then what happens? The crawler crashes, and once it crashes, it loses all its history, doesn't know what it already seen and what it hasn't seen. And once it boots up, it starts by wanting to fetch all the things it hasn't seen, so basically everything. And what that causes, it fetches huge amounts of data, sends them back to our system, and our system at that point doesn't know how to handle that data. Do I already have this data? Should I update it? Should I create new stuff? Because it doesn't have the context of what already happened. So there are a couple other problems, but these two are the most concrete examples of what went bad. So after having to deal with these problems for a while, we started looking for a concrete solution to this, besides having a lot of ifs in our system to see if you already seen something from a third-party API. And after stumbling for a while, we implemented a half-assed solution similar to what Git does. It tracks changes, writes them down. And at the time, we thought that this was a new and exciting thing we have built, but as it turns out, it isn't, and it wasn't. The idea is old, and it already has a name. The name is event sourcing, and Martin Fowler has this big-ass quote where he defined it. So what this quote basically says is that you have the fundamental idea is that of ensuring every change is being tracked. That's the first part. And the second part is saying that all these changes coming in should be in the order that they came into your system. So there should be an inherent order between these things. So let's look at an example to see what exactly is going on in a system that uses this technique. So we have an example of an application that's creating reservations for a conference of some sort. So let's say you want 2 tickets for a conference, webcam conference. You click on the button that says give me 2 tickets. The request gets relayed to the command handler, which in turn asks the domain model, can I have these 2 tickets? And it asks the database, how many bookings do we have? The database responds with the number 623, and the system figures out that, yeah, okay, I can have 2 more tickets because it's less than 1,000, which is how many you are here, I guess. The model then responds with a successful response, and you have your 2 tickets. So that's the usual way of doing things. You just take the data, update it in place, and everybody is happy for a while at least. Event sourcing way to do things would be to record each of these transitions, each of these changes in a separate object that you would store to the database. So in this example, the first part is the same as the second part. The only thing that is different is that for each new reservation, we are creating an event that says, I'm adding 2 reservations to the table. And if you wanted to cancel a reservation, well, in the previous example, you would just decrement the number from 625 to 623. Here, you would have to create a new event that says cancel these previous reservations, because if you were to just delete the event, you would be changing data without tracking it, and that's not a good thing to do if you have event sourcing. So all of these events, when we look at them together and as one thing, they form the application state. Each individual event is one diff, one delta, and all of them together form an application state. Because we define these things, let's see more concretely what are the characteristics of each of these. So what is an event? The event is a value object, meaning that we are only interested in its value. We do not care about its identity or what else it brings, we just want the value. It's immutable, meaning that it's not updatable. It shouldn't be updatable. So in the previous example, we were creating a new cancel reservation event when we wanted to cancel a reservation. We didn't just take the event and delete it. And as I said, they bring new information, meaning that they should be unique. If you're creating events and they have the same properties as an event that's already in your system, there's something wrong with your system. You shouldn't be doing that. So let's recap all events together, taken together, form the application state. So what are the characteristics of the application state? Application state, we also call this entities of the system. So these are the things that have relationships to other things in the system. So you don't want to tie your events with anything else than the entity it's describing. So relationships should be in the entity, not in the event. We're also able to update entities. Well, we are not able to update events, but only through the generation of another event if you wanted to update them. So to see the picture more clearly, let's compare them. Events mutable, entities mutable. Events are about values, entities are about an identity of something. And finally, events bring new information. They are deltas of information, and entities are the sum of the information, the whole of your information taken together. So let's see a real-world example of this. We'll look at GitHub's API. So GitHub, I hope all of you know what GitHub is. It has an internal issue system that it sort of uses it for tracking bugs. It's a ticketing system. So whenever you generate or open a new issue, the GitHub internally creates something that they call an issue event. So you open an issue, they generate an event that says an issue was opened, and they store the change in that event. So if you were to update the title of your issue or update the body, a new issue event would be generated that would say something was updated. You can see the action is updated. And then finally, if you were to close the issue, a new closed issue event would be generated that would say the issue was closed. So after knowing all these techniques, let's see how we use them to tame the monster from the previous slide. Half an hour that took. So let's first define the structure of data. We have the events that basically just have the reference to the entity they are describing or they are tracking. We have the MD5 hash that says if something is occurring again, or use that event with events. And we have the original JSON from the third-party API we're looking at. We also have the entities, which can basically be anything. In our system, they are posts, because we are mostly interested in posts, comments, stuff like that. We fetch APIs to see things changing. So in our case, we have the type, the time, and the body. It doesn't matter what. So let's say we're looking at an RSS feed of sorts. It's a blog, and let's say a blogger publishes a new blog post. So our crawler, which we had an opportunity to see before, fetches that data in the form of a JSON document. We take the JSON document, create an event based off of it, and save it to an event store. So now we have, now our state of the system looks like this. We have an event, we hash that calculation, and we have a JSON stored somewhere. But it still doesn't know which entity it's supposed to modify or create. Then we take that event, we create a new post event based off of it, post entity based off of it, and store it to the database. So now we have, this is a new state. Because the system saw that there's no previous post in our database, it created a new post based on the data that the event brought with itself. So let's say, I hope you noticed that there was a typo in the title of the blog post, and the author figures that out, updates the title of the blog post. Our system sees that and fetches a new JSON document. Then comes the creation of the event based on that JSON document, and we of course again store it to an event store. So the new state looks like this. We have the event, we have the new event, and the MD5 has changed because some content in that JSON document changed. So based on that event, we create an entity again, but because we already have an entity in our database that represents the same thing, our system figures that out and just updates the entity that is already in there. So what do we get by doing things this way? This is a pretty complicated way to do things. Well, we solved all the problems we previously defined. We solved the first problem by being able to track changes. So now we have an entity, and whenever something goes wrong, we can just look at all the events that change, cause the mutation, cause the data to change. So if you have trends in bugs, you just find the event that caused that and see what happened. We solved the second problem. We are able to filter out noise by just comparing the MD5 hashes. If the same data is coming in, you just reject the event and you're fine. And it was a natural solution, meaning that it was really easy to do this because, as I said, when things get complex, you write them down. So we were just basically writing down what was happening in our system. In fact, I think patterns usually, because event sourcing is a pattern, are just, if there is a pattern, it just means that many other people had the same problem you had and somebody generalized it. And what else did we get with this? There are a couple of interesting features and possibilities of this system. So you're able to completely rebuild the state of your system, meaning that, let's say you have a bug that we talked about, and something is wrong, you find the code that caused that bug to happen, you fix the code, and then you just completely rebuild the state of your system without the user ever knowing that there was a bug. You don't have to pause your system, you don't have to tell the users something went wrong, sorry, we are fixing it, we'll be back online soon. You just rebuild the state, store it, and that's it. Another interesting thing is that you can do temporal queries of past states, meaning that you can just select the timestamp of the event, replay them, and you have the state for that particular month. That's, for example, an interesting use case in billing systems. Some billing systems pause their system so to prevent new data coming in and then generate receipt. This way, you can just select all the events, replay them, get a new state, get the state you're interested in. And finally, it's not finally, but it's easy to capture business intent, meaning that there's much more meaning assigned to an event that says there were 2 new reservations in your system than there is meaning in a column that says 623. So much more meaning in your system and in the data of your system. And finally, it goes very nicely with the functional programming philosophy, which I kind of did, which says that basically you should be mutating your data structures, you should only be appending stuff. And this is a very nice fit. Of course, there are some downsides to this. It's more complex, obviously, because you have to have a system in place that generates these events that instead of just updating them. And it's especially hard to do this thing if you are doing it retroactively, meaning that you're retrofitting an existing system with this new technique. Because, for example, you have many updates spread all across your application, probably as I do, and you have to replace all those updates with a code that generates and applies events. And that's not an easy thing to do. And finally, there's the problem of event, meaning that there exists time period between generating an event and applying the state of that event to create a new state. Let's take shopping cart, for example. Your user adds an item to a shopping cart, your system generates an event, and user reloads the shopping cart, but he sees that no items are in the shopping cart. That's the time it took the system to apply the event and generate a new state. So there's that. If you're working in a domain that needs real-time responses, you shouldn't be using this. So that was it. I hope that you learned something from this, and I hope that there are some questions you're interested in.
Hi. So, 2 questions. First of all, when you generate a new event, are you doing a diff between the 2 documents, or are you just storing the whole document?
No, I'm just storing the whole document.
Okay, and what do you use to store events and entities?
Postgres, it's awesome. It has JSON stored.
Can you repeat it?
Oh yeah, the question is what do we use to store events? We use Postgres because it has a native JSON store now. And it has really fast inserts and updates.
What about actions that mutate multiple entities?
Actions that mutate?
Actions that need to be applied to multiple entities. Is it event for
you
each
don't do
entity?
that. If you need to apply one event to multiple entities, you create a new event in your code that says this event called mutation of several entities.
So who is it associated with? Do you then do one-to-many between the event?
No, one-to-one with generation of new events that map again to this entity.
Okay.
No, so you generate, so each time you want to, if one event causes many entities to change, then that entity generates new events that record that. Just duplicates the event, so because there's always one-to-one relation between the mutation and
I think he was asking about the problem of eventual consistency across aggregating boundaries, because he wants to update 2 routes with one event. Is that the problem that you're Slide 2 or 3. When you show that now the ticketing system is so much simpler, you can just explain to us how does the system
What's the slide? Sorry.
like number 3, I guess, like the the one that adds reservations. So could you just explain to us how the system ensures that there are reservations to give out?
There are what to be?
Reservations for tickets, you know?
Oh, so how the question is how to.
Yeah, because you don't have a lock here, so how does the system work?
I'm sorry, I didn't understand you. How does the system work?
I want 2 reservations.
Yeah.
And how do you make sure that you do not store an event which gave out 2 reservations if there are none to give, if they're all out? How do you solve concurrency, basically?
Interesting question.
because your problem which you were attacking does not have this kind of issues. So
Yeah, well, I don't know. I have to think about it. We can talk about it later. Sorry.
Hi, how do you determine the event ID for different sources?
How do I determine the event ID?
Yeah, but I've been doing things with some dodgy RSS feeds as well. It's sometimes difficult to determine the ID of a certain post on the RSS feed because there is no unique ID on them.
Yeah, that's one of the problems that I didn't mention in this talk, and it's dealing with these malformed or bad quality sources. So whenever you have a situation, for example, where you don't have the identity assigned to the post you're looking at, that can be a really hard problem to solve because you have to create special kind of digest to see is it the same as something else, and that's it. Yeah, it's a hard problem.
Okay, so here you're presenting event like this solution, but in this case, each entity has basically only one value. So you are solving, if entity has more properties, you're solving this by having a JSON object in Postgres.
Well, depends what the entity is. In our case, it's post, so we don't need to have many columns that describe the thing.
Yeah.
If there are columns, so if there are columns that are varying between different sources, for example, Facebook has a concept of, I don't know, something, and Twitter doesn't have, we store the differences in a JSON assigned to that entity. So we don't have a column for everything that the original thing has in its source, if that was the question.
Yeah, so it's basically it's possible to implement this system only by using the database with a capability of having like stored entire set of data in one column like JSON or something.
Yeah,
like this.
I mean you could do it even without that, but that's a nice feature to have if you're doing this kind of thing.
Any more questions?
You need to run.
Hi. Let's say you have a chain of events, and for example, you said that if you have one event that updates multiple entities, that you generate several new events. And what happens if one of those events doesn't apply? For example, database for that is down or something. So the transaction is partially updated.
Yeah, so if you lose an event, that's lost state. But what we do in our case, meaning there's no fixing that from inside the system, but what we do in our case, we have multiple instances of the crawler. So if one misses something, the other one catches it. But if we lose it internally, that's it. We have no way of knowing that occurrence happened. It's losing history.
That's it? Okay. Thank you, Nikica.